started. Now let's say I want to verify whether this multiplication is correct or not. That is 247 into 512 is indeed 125464 or not. So the first thing that we need to do is we need to add up the digits of the multiplicand. Basically in any multiplication, the number at the top is called the multiplicand, right? So here we go. 2 plus 4 plus 7. Now this adds up to 13. Now if the resultant summation is more than a single digit number, is not a single digit number, basically any number greater than 9, we would again add up the digits of that number, right? The resultant summation. So 1 plus 3 equal to 4. So we would continue doing this process till we reach a single digit number. Now as we have reached a single digit number here, we don't have to do anything more. Let's say instead of 13, this summation would have come to 29, right? In that case, 2 plus 9 equal to 11. We would have had to add up the digits, and then we would have gotten 2. So basically we would first add up the digits of the number, and then if the resultant summation is more than a single digit number, you would again add the digits of the number, and we would continue doing this till we reach a single digit, right? Now incidentally, this number also happens to be called the digital root or the digital sum of a number. Now, what is the digital root or the digital sum of a number? The digital root or the digital sum of a number is the iterative sum of the digits of a number till we reach a single digit, and in each iteration we use the result from the previous iteration, right? So similarly, let's add up the digits of 512. So 5 plus 1 plus 2, this comes to 8. Right now, as we have got a single digit number, we don't need to do anything more here. Now, one important thing to note is if either of this number would have been, let's say, a single digit number, then we wouldn't have to do anything at all. We would be fine. Like in that case, we wouldn't have to do all these calculations and all, right? So now we want to verify whether this multiplication is correct or not. So what we do is we draw a cross or X, whatever you call it. Now write the digital root or the digital sum of the multiplier on one side, the digital root of the multiplicand on another side, then multiply this two. So 8 into 4 equal to 32. Now as again we have a double digit number, we would again reduce it to a single digit number, like find the digital sum of that number, right? So 3 plus 2 equal to 5. Now if this multiplication is correct over here, then the digital root or the digital sum of the product would be equal to the number over here at the top. That is, it would be equal to 5. So let's add up this number. So 1 plus 2 plus 5 plus 4 plus 6 plus 4. So 6 plus 4, 10, 10 plus 4, 14, 14 plus 5, 19, 19 plus 2, 21, 21 plus 1, 22. So as it's a two-digit number, again we would have to add up the digits. 2 plus 2 equal to 4. Now we get 4 over here. So now what did I say? I told you that if the multiplication were to be correct, then the digital root of the product would have been equal to 5 or the number at the top, right? So it's not equal to 5, it's 4 here. So there must be some mistake in our multiplication here, right? Now I did the multiplication purposely wrong just in order to demonstrate the process. So the mistake is here. Instead of 5, this would be 6. You can pause and check it. In that case, what would be the digital root? So instead of 5, this would become 6 here, right? This would become 23, this would become 3, and this would then become 5. So once we have the correct product, this digital root or the digital sum of the product will match the number at the top. So now our multiplication is correct. Now one important thing that needs to be pointed out here is that when we are calculating the digital root or the digital sum of any number, we don't need to add all the digits, then arrive at a double digit number, and then again add up the digits to finally reach a single digit number. We can actually add up the digits, like in the course of our addition. Whenever the summation becomes a double digit number, we can reduce it to a single digit number by adding the digits there and there. So what I mean is, basically, let's say I want to find the digital root or the digital sum of this 126464, right? Here what we did is we added up all these numbers, reached a two-digit number, and then finally adding the digits of that two-digit number, we reached 5, right? Instead, what we can do is we can keep on reducing the summation to a single digit number whenever it reaches a double digit in the process of calculation. So let's say in this case 6 plus 4 equal to 10, right? Now it's a two-digit number. 1 plus 0 equal to 1, 1 plus 4 equal to 5, 5 plus 6 is equal to 11. So it's a two-digit number. 1 plus 1 equal to 2, 2 plus 2 equal to 4, 4 plus 1 equal to 5. So you see, basically we get the same result. Basically, you can find the digital root or the digital sum in this method also. The advantage of this method is that you would be able to find a digital root way faster. It's much easier to reduce the double digit number in between, then reach a big double digit number and then add the digits of the number to reach the digital root. Now another important thing that's to be noted here is that most of the times when we come across multiplication of large number, more often than not those happens to be decimal numbers, right? Now the question is this method valid for decimal numbers? The answer is yes. Why? I mean, it's obvious that it would be valid, but for those who having any sort of confusion, let's convert this into decimal multiplication, right? 24.7, and let's put a decimal point here, 5. So it becomes 24.7 into 5.12. In that case, the multiplication would be the same as 247 into 512, and then we would be just counting the number of digits after the decimal point in the multiplicand and the multiplier. So 1 here, 2, 3, a total of 3 digits after the decimal point in the multiplicand and in the multiplier. So we would put the decimal point before 3 digits in the product. So as you can see, the multiplication between any two decimal numbers would be the multiplication of those two numbers without the decimal point, and then we add up the number of digits after the decimal point in the multiplier and in the multiplicand and put the decimal point before those number of digits in the product. Now another important thing to note is here is this, that this process is 99.99% accurate. Now you may ask, what about the other 0.01%? Right? Now it may so happen that you get your multiplication wrong in such a way that the digital root of the wrong product happens to be equal to the digital root of the product that should have been there if your multiplication were correct. Let's say we make a mistake here in such a way that instead of 6 we get 5 here, and instead of 4 we get 5 here. Right? So this decreases by 1 and that increases by 1, right? So the digital root would basically be the same, but the chances of this happening is literally 1 by 10,000, right? So for any exam purposes or real life purposes, I would say you can reliably depends on this method to verify your calculation, right? Okay, so now what we will do is we will move on to some advanced method through which you would be able to verify your multiplication even faster, right? So let's go. Before we proceed any further, if you have learned something new and helpful in this video till now, do hit the like button. It helps me a ton with the YouTube algorithm, and most importantly, it's free. You don't pay anything for that. So yeah, go and hit the like button. Now coming back to wherever we were. So the method we are going to learn now is called casting out 9. What this rule basically says is that when reducing any number to a single digit, if any digit of that number happens to be 9, we can directly replace that 9 by 0. Right. Also similarly, if any set of digits in that number adds up to 9, we can replace them by 0 too. Like here 8 plus 1 is 9. So you can just replace 8 and 1 by 0. So this number when reduced to a single digit will automatically become 7. Now instead of adding up all these numbers and then reducing the double digit number to a single digit, we can directly write 7 here. Now one may ask why we just can replace 9s by 0s, right? So the reason is very simple. Whenever we add 9 to any number, the sum of the digits doesn't change, right? For example, let's take 26, right? So 26 plus 9 would be 35. Now see what happens here. The digit in the units place decreases by -1, and the digit in the tens place increases by +1. So +1 -1 cancels out, and hence the summation of the digits remains the same. So 6 plus 2 is equal to 8 here, 3 plus 5 equal to 8 here. So basically that's why you can directly replace it by zeros, because it doesn't change anything, right? Now another important thing to note is that after reducing the numbers to a single digit, if the single digit comes out to be 9, a lot of people prefer not replacing it by zeros once they reach single digit, right? So you can either keep it as 9 once you reach single digit, or you can replace it zeros there also. It's totally your choice. Do whichever you are comfortable with, right? The rule basically says is that after the two numbers that are being multiplied is reduced to a single digit, if any of the single digit happens to be 9, then the product reduced to a single digit will give us 9 if the multiplication is correct. In other words, if the digital root of any of the multiplier or the multiplicand is 9, then the digital root of the product will also be 9. If you prefer replacing 9 by 0 even in the single digit case, you could say that if any of the two numbers being multiplied when reduced to a single digit is 0, then the product when reduced to a single digit will also be 0 if the multiplication is correct, right? Alternatively, if the digital root of any of the multiplier or the multiplicand is 0 or 9, then the digital root of the product is also 0 or 9. So how this helps us is that if you once find that one of these two numbers digital root is 0 or 9, then you don't have to find the digital root of the other number that's being multiplied. You can directly go to the product and check whether its digital root is 0 or 9. Basically, when reduced to a single digit, whether it is 0 or 9, right? Now we have a third rule too, which is basically a corollary of the second rule. That is, if any number is multiplied by 9, then the digital root of the product will be 9. Right, so if you multiply any number by 9, you don't need to find the digital root of the other number. You can directly check whether the digital root of the product is 9 or not to check whether it's correct. If you replace 9 by 0 even in the single digit case, it becomes all the way more intuitive. Let's see how. Now, if any one of the number that's being multiplied when reduced to single digit gives us 0, then we don't have to reduce the other number to a single digit because anything multiplied by 0 is 0. Right? Now we know according to the rule that the multiplication will be correct if the product when reduced to a single digit is equal to the number at the top. So here it's 0, so it has to be 0. So basically we see that if one of the numbers that's being multiplied when reduced to a single digit is 0, then the product when reduced to a single digit has to be 0, right? Now let's apply all these rules on this sum that we have here, right? Now we can see the multiplier is 54, right? So 5 plus 4 equal to 9. So we don't have to calculate the digital root of the number above. We have to directly check whether the digital root of this number is 9 or not. That is when this number is reduced to a single digit, whether it's 9 or not. So 4 plus 9 is equal to 13, 3 plus 1, 4, 4 plus 6, 10. But 10 is means 1, 1 plus 9, 10, again 1, 8 plus 1, 9. So this multiplication is correct. If you have made it till here and liked the video, do hit the like button, and if you want to see more such videos in the future to sharpen your calculation, do hit the subscribe button. We are going to bring in a plethora of mathematics video, calculation tricks video, which will greatly be helpful for you. And if you know somebody who will be helped by this video in your friends and family, do share it with them over WhatsApp, Telegram, or over any other platform. Thank you, bye, ciao, see you in the next video.